in the serial port, the COM7 option is being selected. Then create new connection.
Okay, sir.
Wait until the status shows it is connected. So now it is connected. So once you get this status as connected, select that and change the speed to 2,50,000. Enable bus has to be in check. Once all these conditions are done, then save bus settings. Then you can see in the background number of data are being logged. So once that is confirmed, you can close this window. Right now it is generating raw data from the system.
Raw data means?
001.
I mean in the 2's complement, CAN data is being transferred here. Whatever the data that is coming from the load cell, it is directly displaying it in the computer readable form. We have to convert this to how we can read. To do that, interpret frames. There is an option for interpret frames.
What are these data will refers?
You'll get to know in once I convert these data.
First is this load cell data.
Yes, yes. I mean not only load cell data, complete system.
It's complete system data.
That is connected to the motor controller as well. It is connected. So it will show all the parameters. Currently, since it is in raw data, you cannot get to know what data are being displayed.
These data will refers to the now initial condition.
Yes. So once I click the interpret frames, you can see number of parameters get displayed here. Click on expand all the rows. Here you can actually see what are the data that are getting logged here.
This is file for DBC file where we convert all this hexadecimal into certain parameters, maybe such as motor controller parameters. Either it is becoming an hexadecimal way, now we convert it into certain parameters.
Okay. All are coming from hexadecimal only.
Yes,
All the data.
all the data. I mean, after this step, next main step is to load the DBC files so that it logs only the specific data that we require for our system and analysis. So to do that, go to files. Here you can see DBC file manager.
DBC means? Data? Load controller. Then what is?
Database controller.
DBC file.
Digital to binary converter. Decimal. Decimal to binary.
I'll let you know on that what the DBC is. I'll ask the simulation engineer and
Database scan.
Database scan.
so here two of the systems has to be connected. One is HX711. Both the files will provide that. Here you can see the load option here.
So DBC means database.
Database scan. The extension also will be coming same in the .dbc.
So once you click on that load, you will get these options. Load both the files, portal controller as well as HX711.
So every time we have to.
Now, every time it is not required. At the starting, here I have already loaded it once, so that is why it is getting displayed by default. So at the beginning of the first experiment, you can do it. In the later on, you need not add every time.
Presently, this is your personal.
Yes, yes. Presently, this is my personal. We'll give a separate system which has every software and. So once you follow all these steps, the next thing you have to note down is the MCU voltage. Here it is showing 49.7. So to conduct the experiment, the voltage window has to be between 48 and 54 volts. This is for the safety limits. We are limiting the voltage value to be between, yes. I mean, motor controller reads the data from the battery. So currently the battery is at 49.7 volts. If it is anywhere less than 48 volts, keep the battery to charge.
So this is the indicator.
Yes,
It's
this
displaying,
is,
right?
yes, it is displaying here. 49.7 volts. MCU voltage.
So it's real time, huh?
It's real time data. Once this is confirmed, next just to confirm the load cells that it is not applying any load. To confirm that, check this column here. CAN data 24. Here you can see kg1 and kg2. The value should be minimum, that is 0.8 or less than that. If it is 0.8 or less than that, it means no load is being applied.
Basically, that weight is the weight of the belt, huh?
Weight of the belt, the setup.
Titanium.
If it is anywhere more than that, gently loosen it.
Which one? KG1?
kg1 and kg2. Any of this, let any of these be more than 0.8, gently loosen the front hand wheel.
So anyway, we will,
Only that.
Yes, you can check as well.
so anyway, we want the difference. So I think it will cancel out.
Yes,
0.7 and 0.8 will cancel out.
correct.
Tighten it.
Hello,
He's tightening it.
Sir, you
Correct.
simply pull it from here. You can see whether it's working or
No,
not.
I cannot pull from there like that.
Lock. ರಿಫ್ರೆಶ್ ಆಗುತ್ತಾ ರಿಯಲ್ ಟೈಮಲ್ಲಿ ಅಥವಾ ನೀವು ಏನಾದ್ರು ಸ್ಕ್ರೀನ್ ರಿಫ್ರೆಶ್ ಕೊಡ್ಬೇಕಂದ್ರೆ
ಇಲ್ಲ ಇಲ್ಲ ಅದೇ ರಿಫ್ರೆಶ್ ಆಗುತ್ತೆ. ಸಿಸ್ಟಮ್ ಸ್ವಲ್ಪ ಸ್ಲೋ ಆಗೋಗಿದೆ.
Expand.
Should be less than 0.8.
Kindly tolerate with this. The system has gone slow.
Expand.
So once you connected the software, you just saw multiple values getting logged before the experiment. So first step is you have to clear the frames. Here there is an option, clear all the data. Then click on this overwrite mode so that this logging doesn't start yet. So once you click on this overwrite mode, you'll get an option here. Click on yes. So you'll get displayed 4 number of datas here. Oh, manual. So when 4 data gets displayed here, I mean 4 CAN IDs, it will be in jumbled format. You'll have to make sure you arrange this in ascending order, so that accordingly the data gets sorted out. You need not further put your efforts to sort the data once the log file is with you. So that is why in the CAN software itself we'll arrange the data in ascending order. To do that, just double click on this ID. So the CAN ID is here, 22, 23, 24, 25. It is arranged in the order. Here 22 and 23, it is from the motor controller. And 24 and 25, it is from the communication board. So let's say just switch on the MCB. Yes, it is switched off. I mean switch off, I'll just show another case.
Load should be removed. It's loaded.
No, yeah, we have to loosen it.
Wi-Fi ಬೇಕಾ? Should be connected to net.
No. Wi-Fi is not required. It can work in offline.
ಬಸ್ಸಿಗೆ ಏನು ಫುಲ್ ಫಾರ್ಮ್ ಇಲ್ಲ.
See now, the MCB switch is off. That is why it is showing only two datas here. No, only two datas are being displayed.
So motor
24 and 25. This is from the communication board. Only this is getting read because it is connected. But the motor controller is off. That is why CAN data 22 and 23 are not displayed. Now once you switch on that, even those two datas will be displayed here.
ಆನ್ ಮಾಡೋದಾ?
So now you can see all the four datas are displayed because the motor controller is on. Double click on this ID, it will be arranged in ascending order. So now the software has been set up to log the data from the experiment. So once you uncheck this overwrite mode, it starts logging the data. So now when the software is set up, we will go to the experimental part.
Interpret frames ಚೆಕ್ ಆಗಿದೆಯಲ್ಲ ರೀಡಬಲ್ ಫಾರ್ಮ್.
ಅದು ಯಾವಾಗಲೂ ಚೆಕ್ ಆಗಿರಬೇಕು ಇಂಟರ್ಪ್ರೆಟ್ ಫ್ರೇಮ್ಸ್.
ಏನಲ್ಲಿ ವ್ಯಾಲ್ಯೂ ಚೇಂಜ್ ಆಗ್ತಿದೆಯಲ್ಲ ಯಾವುದ್ರದ್ದು ಅದು ರೈಟ್ ನಾವು ಫ್ಲಿಕ್ಕರ್
ಅದು ಡೇಟಾ ಲಾಗ್ ಆಗ್ತಾ ಇದೆ, ಓವರ್ ರೈಟ್ ಆಗ್ತಾ ಇದೆ.
Okay.
ನಾನು ಓವರ್ ರೈಟ್ ಚೆಕ್ ಮಾಡಿದ್ದೀನಿ
ಓಕೆ ಓಕೆ
ಬಿಕಾಸ್ ದ ಸೇಮ್ ಡೇಟಾಸ್ ಆರ್ ಗೆಟಿಂಗ್ ಓವರ್ ರೈಟೆಡ್ ಆನ್ ಈಚ್ ಅದರ್. So now let's start with the first experiment. So the first experiment is no load test. Here we'll check current and voltage parameters with respect to speed, how it varies. Why we conduct this test is because if there are any leakages within the motor, there will be huge number of current being drawn to the to power on the motor. So the motor vendor will give a specific data. This is the amount of current that it should draw at particular speed. So if it is drawing anywhere beyond that, it means we have to check that there are any faults within the motor. That is how we'll get to know the faults in the motor. So to do that, make sure no load is being applied. Just to verify, click on expand all the rows. You'll see here 0.8, 0.7. If it is anywhere within that, it is fine, we can start. No load is being applied. And one other thing is voltage. It is within 48 and 54. So we can start with the experiment.
Can be after.
ಇಲ್ಲ ಇದನ್ನು ಅಲ್ಲ ಇದು ಮಾಡ್ಬಿಡ್ತಾರಂತೆ ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್ ಮುಗಿಸ್ಬಿಡ್ತಾರಂತೆ ರೆಕಾರ್ಡ್ ಮಾಡ್ತಾರೆ.
So once it is confirmed, both the fans are running. then check the throttle here. It has to be at initial position here. Here there is a marking. Here on the left you can see a marking. It has to be in the initial position.
ಲಾಸ್ಟ್
ಅಲ್ಲ ಎಂಡಲ್ಲಿ ಇದು ನಾವು ಟೋಟಲಿಗೆ ಮಾಡಿದ್ರೆ ಇದು ಮೇಡಮ್ ಇವಾಗ ಅಲ್ಲ ನೀವು ಹಿಂಗೆ ಮಾಡಿದಾಗ ಗೊತ್ತಾಗುತ್ತೆ ಇದು ಹಿಂಗೆ ಮಾಡಿದಾಗ ಗೊತ್ತಾಗುತ್ತೆ ಇದು ಎಂಡಲ್ಲಿದೆ ಇವಾಗ ಹಿಂಗೆ ಇವಾಗ ವಾಪಸ್ ಹೆಂಗೆ ಇವಾಗ ಫ್ಯಾನ್ ರೆಗ್ಯುಲೇಟರ್ ಅಂತ ತಿಳಿಸ್ತಾರೆ ಫ್ಯಾನ್
ಈ
ರೆಗ್ಯುಲೇಟರ್
ಡೈರೆಕ್ಷನ್ ಇದ್ರೆ ಓಡುತ್ತೆ. It starts logging. So now gradually increase the throttle from 0 to maximum. Stay there for 5 seconds. Then gradually the same pace get the throttle back to initial position. Once this test is conducted, when you bring back the throttle from maximum to initial position, just verify this total number of frames. It has to be at least 10,000 frames minimum, so that the final graph which you get will be much smoother.
So how many frames are captured per second? 70
Frames per second you can see here. So
Okay. What's there? Okay. So that is actually the signals which are captured so much.
yes. So these many data are being captured here. So once it is beyond 10,000, it is fine. We can click on suspend capturing. Now the log file is being present here with you. The next step is you have to save this log file. Always make sure interpret frames is on. Suppose if it is not in check, again you will have to conduct the experiment, because only the raw data gets logged. You cannot read any data from that. So to save this log data, go to File, Save Log Data. By default, this will be in CSV format, and make sure you give a ideal name for this. Follow some nomenclature so that you can differentiate between the tests. So for this, I have given MTV, motor test bench, test 2, because I already have test 1 data here. So test 2, and it is for the no load condition. So I have added no load here. So right now, which I saved is only the log data. Now I'll have to save the decoded log data. To do that, go to the files. Here you can say save decoded frames, CSV. Click on that. give the same name so that it doesn't get confused which test and which data. Just make sure you add decoded keyword so that you can differentiate between log file and decoded file. And this decoded log file, by default it will save in text format. You'll have to make sure you add .csv in the end, because we have developed a test plotter software, so it reads data in the CSV format. So once you import that CSV format, it can directly plot the results for you. So it is checked, it is in .csv format, no load. So now both the files are saved. Then this is the only part of the software, Savikan, only to log the data and save the data. To plot the results, we have another software here from the decibels only. We have this test data plotter software, and here you can see number of buttons here. These number of buttons are for plotting different test results for different experiments. For the no-load test, we'll make use of only those buttons which we need for the no-load test. So the beginning step is to load the log file. Right next to this button, you can see a green button here. Currently, it is in dim condition. So you can see the difference once I log the data. Click on load. Test data, and just load the decoded file. If you load this direct log file, it will not be of any use, it will give error data. Always make sure you load the decoded file. So you can see the green button glows. So with this, it is confirmed that log file is loaded successfully. So for the no-load test, as I mentioned earlier, we'll be checking for speed with respect to current and voltage with respect to speed. So for that, we have an option here, plot current and speed. This is the current and speed with respect to time. As you can see here, we started the throttle from initial position here, that is speed 0, and we increased it to maximum. And gradually we again waited for 5 seconds to 10 seconds, and we gradually decreased it. That is the red plot which you see here. With respect to that speed, how the current is changing. That is represented here in the blue column here, the blue curve. So right when we increase the throttle to the maximum, the current drawn will be to the maximum. Here in this case it is somewhere around 15.5 or 15.3 amps. Then it stabilizes at certain point. So you can actually take the average of this. Just by moving the cursor over this curve, you'll get the particular results at that point. Here you can see the data in the X and Y. So 9.5 amps it is drawing at this particular time step, 606.904. We can even verify the same with respect to speed. So now 9.5, at what speed it is drawing the data. We can hover the cursor here and see what is the RPM value at that particular amps.
So voltage will remain the same.
Voltage, it will be exactly opposite to the current profile. So this is how the voltage curve will be. Voltage, it was initially it was at 49.7. It started there, and once I increase the throttle to the maximum, at the maximum you can see it has the maximum voltage drop, and it has the maximum peak current at that point. Then it stabilizes at a point. Here it is somewhere around 47.9. So this is about the no load test. You can actually save this plot results by going to this option here right next to the title block. Here you can see a arrow symbol here. In that, go to the third option, copy as vector graphic. Why we go with this copy as vector graphic is sometimes the graph results may not be visible clearly when you put it in the report, in the Word file or something. But when you copy this image as vector graphic, even when you zoom the data, the clarity or the pixels doesn't diminish.
Can I get the array file of that entire graph?
Yes, I'll just show you. This is the decoded Excel file of this test experiment. So in the first experiment, we'll only look into the motor speed and MCU voltage, MCU current. These three data are considered for first experiment.
Plotting.
For plotting.
Even I can plot it over here also.
Yes, even here you can plot it. But it is made easy so that it consumes less amount of time. Yeah. Because a lot of data is there, the system will get hanged when you use Excel to plot this data.
What is that? The logic behind the graphs?
Actually,
What did you suggest? What parameter?
the variation of voltage and current, that is with respect to speed, you will understand that when you do the cell testing, because that is the chemistry behind the cells, and that is how the cells